This is the first in hopefully a series that the Climate Action Group, the Green Team at CCDC Church is hoping to sponsor. So thank you most of all to Dr. Osterberg for agreeing to start us off. And you know, sometimes there's a disconnect between research scientists and the general public, a communication breakdown. But Erich, I met him. He worked and volunteered his time in a climate leadership group, and he's clearly a talented communicator as well as research scientist. So, and is generous with his time, as you can see here, in reaching beyond his classroom and lab to the general public. So I just want to thank you again for coming, and I'm glad we'll be able to record this and get the word out.
Great, thanks, Bruce. So yeah, hi folks, I'm Erich, and I'm an associate professor in the Earth Science Department. I'm actually right now just right across the street from CCDC in the Fairchild building. So I'm a climate scientist. I spend most of my time studying the climate of the polar regions, but more and more over the last decade or so, I've been focusing on climate change right here in New England and in the Upper Valley. So I'm going to focus mostly today on sort of the Upper Valley, New Hampshire, but we'll venture a little bit beyond there to think a little more regionally and even globally about climate change. So I want to start with just something you may have seen in the news over the weekend, and this is the crazy record hot temperatures over 100 degrees. It's 100.4 or something, all the way up in Siberia, well above the Arctic Circle. And I think you always have to be careful when you see anything in the media like this. You know, are they just cherry picking some spot? But I can tell you that climate scientists like me are, we noticed this, we were shocked by this. This is unusual, and it is part of the trend that we know has been going on for well over a century here. So what I'm showing here is the temperature of the surface of the planet over the last 140 years or so. So on the left, you can see it goes back to 1880. On the right, it goes all the way up till present. In fact, this last data point here on the right is 2019, which you can see was the second warmest year on record. So you can clearly see that this is global warming. The Earth is warmed by over 2 degrees Fahrenheit, which is a lot in Earth science terms, in geology. And it's rising really fast, like crazy fast in terms of geology again, in terms of how the Earth normally changes its temperature. And if you want to think about just right here, essentially New Hampshire and Vermont actually looks very similar to this global average. We've had a similar overall warming. And actually the timing of it, with that little dip in the middle of the 20th century where it was kind of flat or even cooling for a bit, is pretty consistent here as well. So a natural question that people ask, and you should ask, is, you know, how much of this is actually caused by humans? How much of this is just a natural warming cycle, right? How much are we to blame for this? And therefore, how much should we act to stop it or reverse it? And so you could imagine, what I'm showing here is again in times. On the left is 100 or so years ago, and on the right is today. And if you look at that top curve that's labeled observed warming, you could imagine perhaps we're in a natural warming cycle. And then the difference between whatever is natural and what we've observed would be the human caused part. And so if we're in a natural warming cycle, then it's possible that actually all the warming is natural, or a portion of it is natural, and therefore maybe the human caused part isn't all that big of a deal. You could also imagine that maybe we're actually part of a natural cooling cycle right now, in which case what I'm showing in the top is the exact same observed warming curve. I'm just showing the natural cooling cycle, and then the difference would be a really big human caused warming signal, right? We would actually be compensating for nature and then causing warming on top of that. And so it's a really interesting question. Which one is it, right? What is the situation over the last century or so? Well, the only other thing that really would change temperature on these timescales is the sun. So either changes in the Earth's orbit around the sun or changes in the strength of the sun itself. We imagine that the sun is just this constant ball of energy in the sky, but it's not. it actually changes its strength through time with a periodicity of about 11 years with the sunspot cycle. And that's what's shown in the bottom. So you can see these 11-year cycles, okay, where it peaks and then it troughs, and it's 11 years in between each peak. And then you can smooth those out and see the long-term trend, which is that heavy line. And so what this shows is that during the early part of the 20th century, from the late 1800s till around 1960, the sun was actually getting a little stronger. It was getting a little brighter. And so that would have actually caused a little bit of natural warming. But what's really interesting is that since 1960, the sun has actually been getting weaker and weaker and weaker. In fact, you can see that right now, we're in an incredibly weak period of the sun. In fact, the data here don't even go up to present day. If you keep going, what you see is that right now we're basically entering the weakest sun period that we've seen in a couple hundred years. The NASA scientists call this a grand solar minimum, okay? If you actually go out and look at the disk of the sun with special goggles, you'll see there's basically no sunspots right now. And what that means is that the sun is weaker than normal. And so what has actually been causing the warming since 1960 is the rise in CO2. So it's really dramatic that despite the fact that the sun has been getting weaker for the last 70 years, we've actually been seeing record high temperatures. And it's because of CO2, and that CO2 is from humans. And I'll show you how we know that. So what I'm showing here is an ice core record, and that's one of my specialties. I'm an ice core scientist. So I spent a lot of time looking at these records. And the last couple of plots, we were just looking at the last 150 years or so. Here we're looking at the last 800,000 years, okay? It's a huge number. It's hard to wrap your mind around. 800,000 years. And what I'm showing in the bottom is temperature in Antarctica in red, and above that is CO2 in blue. And you can see there's this huge like sawtooth cycle. And what these are actually the ice age cycles. So I think a lot of people imagine that there was the ice age, meaning maybe one of them. But there were actually lots and lots and lots of ice ages. So every time the temperature is low, that's another ice age. Okay, so each one of these was an ice age. And they were all associated with low CO2. What we've seen over the last 10,000 years is that we've been in a natural period when it's warm and a natural period when CO2 is high. But look where CO2 is now. We're up at 410. And the units don't really matter. All you need to know is we're at 410. And naturally, the Earth was never above 300 for at least the last 800,000 years. And it's actually more like at least 3 million years before we've seen any natural level of CO2 like this. And what's really dramatic too is just how fast this has happened. Some of these changes in CO2, like this one here, these are really fast changes in CO2 as far as natural changes go. But what we see is that this modern human CO2 rise is 200 times faster than anything we can see that happened naturally in the past. So this is absolutely human-caused CO2 from burning fossil fuels, land clearing, all sorts of human activities. And just to give you a sense of the timescales here, the first time our species appears in the fossil record, the first time we have evidence for Homo sapiens on the planet Earth is between 300 and 400,000 years ago. So our species has never before experienced this, okay? This is totally unprecedented. So if we go back to this question, which one is it? This is probably what it is, okay? We had a little bit of natural warming from 1900 to 1960 or so as the sun got a little warmer. But then since then, we should be cooling. We should be cooling for the last 70 years. And instead, because of CO2, we've seen this huge global warming. So I want everybody to be 100% clear. We as scientists, there is 100% confidence that human activities, human CO2 and methane and other greenhouse gases are rapidly warming the planet. There is zero debate about that, okay? We can debate about what to do about that, but let's make sure that everybody's clear about that scientific fact. So this is the way I think about it. Looking back at that temperature curve, the first part is a combination of human-caused warming and natural warming. And then since 1960 or so, it is all from humans. And it kind of disappoints me how rarely you see people just come out and say that. It's in all the IPCC reports. Like, this is not a secret in the scientific community. We just need to get out and say it more clearly, more often. All right, so who cares, right? A couple degrees Fahrenheit, does that really matter? Does that really affect anything? Well, let's think about heat here in the Upper Valley. We can think about it, New Hampshire or Vermont. Vermont has done a really good job tracking how heat affects people's health. And what you might imagine is that you start seeing people go to the emergency room once heat starts getting into the mid 90s or even the high 90s. And what they actually show is that as soon as you hit somewhere around the high 80s, 87, 88, 89, into the low 90s, you're already seeing people affected by heat and being forced to go to the emergency room in order to deal with some health problem. Okay? And then who are these people who get affected? What I'm showing here are the different ages of people. So under 5 years old, all the way up to 75 years and older on the right. And the people who are most affected by this are the people who are in the ages of, say, 15 to 35. And that's because these people spend a lot of time outside where they're going to be exposed to this heat. And the senior population, because this population tends to have more pre-existing conditions that make them more susceptible to heat stress, to heat stroke, and other things that come from that. And so I think a key take-home message is that heat kills, okay? Heat kills. And in fact, if I were to ask you what caused the most weather deaths in this country, you'd probably guess something like hurricanes or tornadoes. I know I would. But it turns out that heat beats them all. And these aren't just cherry-picked from some particular year. This is data from the National Weather Service, averaged over 30 years, okay? So we know that heat kills. And we can see examples of this, really dramatic examples in recent years. So for example, in 2003, some of you may remember this, there was a heat wave that affected Europe, particularly France. Over 35,000 people died, right? 35,000 people died from heat-related deaths associated with this heat wave in 2003. And there's been recent literature out there where we can actually figure out how many of those deaths are caused by human activities. And this paper that came out a few years ago was able to determine that about 70%, so 7 out of 10 of those deaths were caused by human-caused climate change. More recently, in 2010, we saw another huge heat wave in Russia. Here, the estimate is over 55,000 people who were killed in this heat wave. They lost 15% of their crops. They lost at least $15 billion. And I know that in this time of COVID and pandemics, maybe we become a little immune to these kinds of devastating statistics, right? But these are lives. These are families. It's dramatic and tragic to think about the effect of this in terms of where it's coming from, human activities. And again, a paper is able to determine that because of human-caused climate change, this particular heat wave was 3 times more likely than it would have been naturally. So we know naturally we have heat waves, we have floods, those things happen. But what happens with climate change is that we load the dice. We make it more likely that these crazy extreme events happen. And it's these extreme events where we see the most impacts on people. Another thing that my team here at Dartmouth has been studying is the relationship between climate change and Lyme disease. So if we look at the top, what you're looking at is the increase in Lyme disease cases in Vermont. Again, Vermont does a great job tracking this, much better than New Hampshire. So you can see this dramatic increase in cases. Down below are a couple plots from the CDC where every dot here is another case. So you can see that just 20 years ago in 2001, basically Lyme disease was down in southern Massachusetts and Connecticut and New Jersey. And in 2013, it had dramatically spread north into our area. And that's because of the warming. So we've been able to show with our research that as the winters in particular get warmer and warmer, these ticks, the black-legged ticks that we all know about now, are extremely temperature sensitive. They get killed almost instantly if they're exposed to freezing temperatures. And so these warmer and warmer winters means that more ticks survive and they're able to increase their infection and spread the disease further north. And it's not just people. I think equally upsetting is a different tick. This is a totally different tick than the one that causes Lyme disease, but it's also been dramatically increasing because of warmer winters. And what we've seen is a huge impact on the moose population. So some of these moose, they'll find well over 100,000 individual ticks on them. And what they found is that 70% of the moose that they were tracking from 2014 to 2016, these are moose calves, 70% of them were dying from tick infestation. They were just literally sucking so much blood from these calves, they weren't able to get enough nutrients in the long winter in order to survive. It's really dramatic. I spent a lot of time on glaciers. This is a particular glacier that I know a lot about. I take students from Dartmouth to this glacier every single September to teach them how to study climate change. And this is what the glacier looked like in 2017. And just to give you a context, this is what that same glacier looked like 100 years earlier in 1917. And what I've done is superimpose these images so that you can flip between them and see just how much the glacier has shrunk in 100 years. So here's 1917 and 2017. And if I just toggle back and forth, you can see that the mountains in the background stay in the same place, more or less. I did my best, but that the glacier is dramatically, not just further back, but also really much thinner. In fact, it's lost about half of its ice in this last century. And we had a student here at Dartmouth who did his senior thesis on this glacier. He was researching it intensely. And what he figured out is that everything you see in this image here will be gone by 2060. So in another 40 years, there won't be any ice left in this picture, which is really dramatic. And I think perhaps you've seen headlines like this on CNN. This was from last August. Greenland ice sheet just lost 11 billion tons of ice in one day. And it seems dramatic. It's a dramatic picture. The question is, what the heck is 11 billion tons of ice, right? How do you wrap your head around that? Is that a normal amount of ice for Greenland to lose? Or is that a lot or a little? Like, it's really hard to evaluate that. And so a better way to think about it is to look at it again over time and see how unusual it is. So my team went to Greenland and we drilled ice cores to try and figure out how unusual this actually was. And so what I'm showing here is the amount of melt in Greenland going back about 450 years. And so what you see is that the melting that we've seen very recently, which is on the right-hand side of the screen in black, that this amount of melting we have never seen before over the last 450 years. So these numbers really are startling. It really is unusual. And what's really interesting is that when we look at these data, we only see Greenland melting really going into record territory starting around 1995. Before that, it was sort of in the natural range that we saw in previous times. But since 1995, it's been in a whole new regime of higher melt. And so one way to think about this is that Greenland is really just getting warmed up. Even though the climate's been warming for 100 years, it's so cold up near Greenland that it's just now crossed that critical threshold, that critical level where the melting is really starting to increase. And it's not just our results that have shown this. This is something we see over and over again now. And so, of course, when these glaciers melt, one of the things they do is that water goes into the ocean and then the ocean rises, and that raises sea levels. And so I know sea level rise is something people often think about in the future, but I want to make it clear that we've already experienced a lot of sea level rise over the last century. We already have at least 8 inches of sea level rise. Some places more, okay? Some places like down around Washington, D.C., Chesapeake Bay area, all the way through North Carolina, it's well over a foot of sea level rise that they've seen in the last century. So we've already seen this. And here in New Hampshire, we've started seeing not just storms impacting the seacoast and causing millions of dollars in damage, but we've started seeing this just during high tides. So sometimes the high tides are a little higher than normal because it's a full moon or a new moon. And even during those just slightly unusually high tides that you don't even necessarily need a storm, we're starting to see flooding on the New Hampshire coastline because of the sea level rise. And again, this isn't just New Hampshire. We're seeing this down through Annapolis, down into Miami. I just gave a lecture in Miami back in February, just before the whole COVID pandemic started. And it was just shocking to see how close this entire downtown Miami Beach city is to high tide. There's just no room left because they've already lost a foot to sea level rise over the last century. So as we think about the future, the way that I like to think about it is it's a choice. Okay, we have a choice about how warm we want our planet to get. And unfortunately, it doesn't look like we can choose zero. That horse has left the barn. We can't choose zero anymore. We've already warmed up by 2 degrees, and it's going to be really hard to get back to where we were 100 years ago. But if we want to keep it somewhere around, say, 4 degrees Fahrenheit, then what we have to do is dramatically reduce the amount of CO2 and methane that we're putting in the atmosphere. Or if we continue just doing what we're doing, which is what we call business as usual, then we're going to see temperatures that are more like 8 degrees warmer than natural conditions. And that may not seem, again, like a huge thing, right? Like today was probably at least 8 degrees cooler than yesterday. So who cares about 8 degrees? It's the difference between day-to-day weather versus long-term climate. And to illustrate this, I want you to think about the last ice age. So the last ice age here, which was a long time ago, it's 20,000 years ago. But the last ice age, we had a mile of ice right here over Hanover, right over the CCDC. It was a mile of ice, okay? The average temperature of the Earth when that happened was only 8 degrees cooler than natural, okay? So 8 degrees is enough to go from a mile of ice right here to the climate that we saw, say, 100 years ago. 8 degrees is huge in terms of global average temperature. Another way to think about it, again, is in terms of the extremes. So here in Hanover, on average, we get about 1 week a year, 7 days a year, where we go over 90 degrees. I think this summer, we're going to go well over that 1 week. It's already been a really hot June. It's looking like it's going to be a particularly hot summer here in the Northeast. As we look to the future, if we're able to reduce our CO2 dramatically, we might be able to end up somewhere with about 3.5 weeks above 90 degrees in the summer. By the end of the century, that's by 2100. If we just go business as usual, we're looking at more like 2 months, basically the entire summer. All of basically mid-June to mid-August is going to be above 90 degrees. And that's on average. So if you have a hotter summer than normal, like this summer, you could have much more days above 90 degrees. Those are averages by the end of the century. So that's a huge change for us. And if we think about sea level rise, what we're looking at is somewhere on the range of another 2 to 4 feet. I think 1.5 feet, I have to put it there because that's what the scientific data says is possible, but there's no way we're going to limit it to 1.5 feet with the trajectories that we're on. It's going to be at least 2 to 4 feet. The best estimate for New Hampshire, if we keep on a business as usual, is about 3 feet. But what's interesting is if you look at this circle the arrow is pointing to, and what that shows is that you can see there was a lot of lines there that are above my best estimate of basically 3 feet, right? It goes all the way up to 8 feet. So why is it that we have this huge question mark, this huge uncertainty where it's possible that we could go from anywhere from 3 to 8 feet? Well, the problem is that the ice sheets in Greenland and Antarctica are really, really sensitive to temperature. And what we don't know is how fast they're actually going to melt. We know that if you gave them enough time, they would melt dramatically. And I'm not talking 8 feet, I'm talking 25 feet, okay? The question is, how fast do they get there? And that's really hard for us to understand. But there are some concerning things that make us really worried about things above 3, closer up to 4 or 5. I doubt 8 feet, but certainly above 3. And so this is some field work I did in Greenland back in 2012. We were in this area of Northwest Greenland in a place called Thule. And if we zoom in on that, we were studying along these glaciers, and we were studying some of these lakes. These are actually lakes that are covered by lake ice in this picture. And what you're looking at, this is a picture taken by an airplane looking down. And so this is a huge area, right? From the star to the circle is somewhere on the order of 10 miles. And so we were camped down on this lake, and there's polar bears here. And although polar bears are really adorable looking, they're super scary when you are camping in a tent in Greenland. And so we actually have to be awake. Somebody has to be awake all night. We take turns to make sure that a polar bear doesn't come into camp. And if one comes nearby, we wake everybody up and we get the heck out of there. But the next morning, we all were comparing notes about our 2-hour turn at night, and we all heard this really weird sound of rushing water. It sounded like there was a new river nearby that we knew wasn't actually there. So it wasn't until a couple of days later that we actually figured out what had happened. So this is one of those lakes that I was pointing to on the map. And you can see that there's a little bit of lake ice still left on it, but most of it is now water. And it's right up against the ice cap here. And this is a picture we took on August 5th, which was before we heard the sound of rushing water. And this is what it looked like just 10 days later. The whole lake had just disappeared. It had catastrophically drained underneath the glacier and then out to sea, probably in the matter of several hours. That was the sound of rushing water we had heard. And so I'm gonna try and give you a sense. So this hill right here, where you see the water along that hillside, that is this hill right here. And the difference between the dark brown and the lighter brown is the water line. Okay, so that's where the lake used to be. And to give you a sense, this is somewhere on the order of 150 feet. So this whole lake was well over a mile in circumference, and it just woof, it disappeared under the glacier, and then the glacier collapsed into this basin. And so this is what it looks like. What we actually think was happening is that the water was actually going under the glacier and lifting the glacier up. And then eventually the water found a way out to the ocean and quickly drained, and then it allowed this whole part of the ice cap to just collapse down. And so we were able to take some video by helicopter that gives you a better sense of the scale here. So I'll turn it down just a little. So we're taking off here from the edge of the glacier. That was my colleague next to me saying he's crazy, talking about the helicopter pilot who's flying way too close to the edge of the ice cap. But it's a really dramatic scene. It's basically a moonscape. There's no plants here because it's too cold. And then you can see some rivers that are draining off of the ice cap. And then here we go. We're coming up on this huge crater formation. This thing is huge. We actually walked out right to the edge of this before we realized how stupid we were being and realized how unstable the ground was around us. But this thing was massive, and this just opened up in the span of a few hours, and all the water that was under here went off to the ocean and raised sea level. And so what this shows us is that when you mix ice and water, which is what happens when you heat up these glaciers, things happen really quickly and dramatically. It is really easy to melt a glacier. It is really hard to grow a glacier. It takes about 100,000 years to grow these huge ice sheets, the one that covered Hanover here. But it only takes a few decades, a few centuries to dramatically melt these ice sheets back. And so as we think about sea level rise, this is something that I think about a lot. As I said, one thing we know is that if we give these ice sheets, these glaciers, enough time at temperatures that are just 2 to 4 degrees warmer than natural, we're talking about more like 25 feet of sea level rise. And let me tell you how we know that. So remember those ice age cycles I showed you? Well, the last time that we were in a time like today, in between 2 ice age cycles, naturally in between 2 ice age cycles, it was actually a little bit warmer than today. It was about 2 to 4 degrees warmer, which is exactly where we're headed in, say, 40, 50 years. And what we know is if you go down to Florida today, this is the Florida Panhandle, all of this area is covered in rock that was formed during this time period, 125,000 years ago, and it's all limestone, which means it was formed underwater. So this is not from a computer model. This is not some guess at where sea level was. We know these areas were underwater 125,000 years ago when it was only 2 to 4 degrees warmer than today. And so that probably took 5,000 years for the sea level to get to that level naturally. But what we don't know is how fast the glaciers will get here if we push them unnaturally the way we are right now with CO2. And that's why we have these huge uncertainties. And what keeps me up at night are these recent headlines from the last 5 or so years. These are scientific studies that are showing that there may be critical points where we can't stop Antarctica or Greenland from melting this much. It's not that any of us, will see this in our lifetime, or perhaps even our kids, or even our grandkids. But think about this as a moral challenge. What if the CO2 that we hit in our lifetimes dooms future generations to this, and there's nothing they can do to stop it? That is not hyperbole. That is actually what the best science tells us we are heading towards. What we don't know is where that threshold is. All right, so some take-home points here, just on the temperature, and then we'll talk a little bit about storms. So since 1960, all this warming is from us. We've already seen more heat waves. We've already seen disease spreading to new areas. We've already seen sea level rise. I didn't talk much about agricultural impacts, but you can imagine those. And this is already happening and only going to get worse. And so we must, in my opinion, reduce carbon emissions as fast and as much as possible. But we also at the same time have to adapt to the changes that we can't stop, because these changes have already happened and they're just going to continue. So we have to learn how to adapt and become more resilient to these changes. Rainfall is a little bit trickier. So when it rains, it's not like the temperature. It's not like the whole globe just gets warmer with CO2. Unfortunately, places that are already wet tend to get a lot wetter, and places that are already dry, like deserts, get drier. So it'd be kind of nice if with climate change, the wet areas got a little drier and the dry areas got a little wetter. Unfortunately, nature doesn't work that way. The wet areas get wetter, the dry areas get drier. So it's not like just everywhere gets more rain. But let's look in our neck of the woods here in the Northeast. So this was a sort of shocking figure that came out of a report back in 2014. And it was originally plotted in 2009, but nobody really noticed it until it came out in 2014 as this beautiful plot showing that extreme rainfall. So these are storms that give us more than 2 inches of rain in a single day. That's a lot of rain. This is the kind of storm that happens maybe once or twice a year, the biggest rainstorms of the year. Anyway, if you just look at those storms, we've seen a 71% increase in those extreme rainstorms here in the Northeast. And I saw this and I didn't believe it, because I've lived in the Northeast now for 42 years. This goes back to 1958. That's a little before my time, but I would think, I would have noticed a 71% increase in extreme rainfall. So we dug into this, and it turns out that that number was wrong, but not hugely wrong. From our calculations, it's more like a 50% increase. But what's interesting is that it wasn't like a slow increase through time. It was actually a jump. We actually had no change from 1900 until 1995. And then suddenly in 1996, we jumped to a new normal. And that new normal was 50% higher than the old normal. And it's remarkable. And this was done by me and a couple other faculty here, and Wamping Wang, who is our graduate student. He's been publishing a lot about this. And so we followed up this work by trying to figure out what was going on. What kind of storms are actually causing this? And this is what we figured out. We figured out that about half of that jump in 1996 is due to hurricanes. Half of that jump is from hurricanes. And we're seeing bigger, more rainfall coming from these hurricanes because the oceans are getting warmer from global warming. All right, so that's half the jump. And this is consistent with what we've seen, not just here in the Northeast, but around the country. So you guys remember, of course, Hurricane Harvey in 2017. This was a record-breaking storm in terms of the amount of rainfall that fell. Well, research has come out saying that this particular hurricane was 3 times more likely because of climate change, and that the amount of rain that fell was about 15 or 20% higher than it would have been if it had happened naturally at some like really, really unusual event. So again, we're loading the dice, making it more likely, and we're making them more intense than they would have otherwise been. We, of course, remember Hurricane Sandy in 2012, these really crazy images that we saw coming out of the New Jersey and New York coastlines. These are hugely devastating events, tens of billions of dollars, and lots and lots of lives lost, and even larger numbers of lives strongly affected. Here, closer to home, we found that a quarter of that jump, so 50% is hurricanes, But 25%, so a quarter of it, is actually from a change in the thunderstorms in the summertime. And so what's kind of interesting is that the hurricanes happen in the fall, particularly September and October, and then the thunderstorms are happening in July, June and July. So it's not just one season where we're seeing this change. And so this is a couple examples of what I'm talking about. July 1st seems to be a particularly extreme time here in the Upper Valley. July 1st of 2017, we had a thunderstorm that dropped over 3 inches of rain and washed out roads up to Orford. In July 1st of 2013, we had the so-called Slayton Hill slide here, where we had over, I think it was 4 inches of rain in Lebanon, and it caused this mudslide into this brand new housing community here. And so 25% of the story is from these kinds of thunderstorms. And what we figured out is that the reason these thunderstorms are getting more intense is because the jet stream is getting wavier. And so you guys have seen the jet stream, talked about in the nightly news weather or something like that, maybe online. People talk about the jet stream, the meteorologists do. Well, when the jet stream gets wavier, we get more extreme storms. It's a pretty straightforward relationship. And so we can imagine that the jet stream before 1996 wasn't as wavy as it has been after 1996. And we can prove this with data. This is just a cartoonized version of our results. We had another paper that just came out earlier this year where we looked at this devastating flooding down in Maryland in Ellicott City just a couple of summers ago. I don't know if you remember, but this city, Ellicott City, had a 1,000-year flood, the flood that's supposed to happen once every 1,000 years. They had 2 of them in the span of a few years. And these are some of the images. And our research showed that this was 1.5 times more likely because of climate change. And then perhaps you remember a couple springs ago, we saw lots and lots of nor'easters, particularly hitting a little further south down in Boston. And it turns out that a lot of the rest of the jump, so we had 50% from hurricanes, 25% from thunderstorms, well, another 15% come from these nor'easters, particularly in February and March. So we got nor'easters in February and March, we got thunderstorms in the summer, and we got hurricanes in the fall. All of them are contributing to this increase in the extreme storms that we're seeing here in New England. And so this is some of the things that we've seen recently. So we had these 4 nor'easters in just 3 weeks, but even before that, the biggest one of all was in January of that year. That was the 100-year flood. It was the highest flood level Boston had ever seen, over $1 billion in losses, and this is just from one of these storms. And so we know that, we already talked about sea level rise. When sea level rise particularly affects a community is when it's combined with a storm, right? And so this is the flooding that Boston saw from these 2018 nor'easters. Everything that's in blue was underwater for several hours up to a day. But if we think about sea level rise and these exact same storms, this is what that flooding would look like in just another 50 years. Okay, so it's assuming that the storms themselves don't get more intense, even though we just showed that they are getting more intense. But let's just pretend they're not. Just with sea level rise, the same storm that caused this amount of flooding will cause this amount of flooding. And I mentioned that I went down to Miami. In Miami, it's really a really difficult situation. It's really quite upsetting, actually, when you get into a deeper understanding of their future, what's ahead of them. And so the research shows that in Miami, what happens right now on average every century, every 100 years, is going to be happening 2 to 3 times each year. And so all these areas that are in blue, that's the entire city of Miami Beach and lots of the greater city of Miami here. All of these places are expected to be underwater 2 to 3 times a year. And that's by 2055. That's not by the end of the century. That's just 35 years from now. And when you go there, if you go there, go down to Miami Beach, you look at just this massive built up infrastructure that they have on the coast there. And I honestly don't know what they do. Because, I mentioned that all of the rock that's here was deposited underwater 125,000 years ago. The last time it was 2 to 4 degrees warmer. And the problem is that rock is limestone. It is Swiss cheese. You literally, the buildings are made out of, you can just put your finger through the holes in this stuff. The water actually bubbles up from the ground. So you can't even just put up seawalls here in Miami. it's not going to matter. The water will bubble up from below, right through the limestone that was formed the last time it was this warm. So I really don't know what they do. It's, you know, for like New York and Boston, they're going to build seawalls and they're going to protect their cities, and they're going to buy themselves several decades by building seawalls. You can't do that in Miami. So I really don't know what their solutions are going to look like. Ironically, despite the fact that we're talking about more and more storms, climate change is actually also going to cause more summer drought. And I know what you're thinking right now. You can't have it both ways. It can't be wetter and more drought at the same time. And what I'm telling you is that it can, and it is. Okay, it's because more of the rainfall is coming in these bursts, these extreme bursts, and it's warmer. And so we're actually experiencing this right now, right? So this was the last time we had a significant drought a few years ago in 2016. We saw, you know, the reservoirs were down, people's wells were going dry. It was a real problem, especially in southern New Hampshire. These are all the wells that had to be redug down in southern New Hampshire back in 2016. So this was a huge issue in 2016 for a lot of these communities. And so, yes, we're actually going to expect more floods and more short-term droughts in the summer because it's so hot that water evaporates away more quickly. If anyone's been down to Storrs Pond lately, you've seen this. How much has Storrs Pond dropped? They lost 3 inches of water from the pool that they just filled up just over the weekend. All right, they filled up the pool to the brim, and then they lost 3 inches from evaporation because it's been so hot for the past couple days. They had to refill it up today. So we're actually looking at this again right now. I don't know if you saw the headlines. We're in unusually dry conditions. This came out just last week. We also had a low snowfall year over the winter. Those of you who are skiers know this. So it means that the groundwater was already unusually low to start out the summer season. And now we've got this intense heat. We are way below our normal rainfall, including, you know, even if you include today's rainfall, which was nice, but is not gonna pull us out of these dry conditions. We're gonna need a lot more of these sorts of storms to get out of it. But this has got people concerned looking for this summer. So some take-home points here. In general, across the globe, wet areas will get wetter, dry will get drier, but around here, we're actually kind of seeing both. We see more of the downpours causing more flooding, and that's from hurricanes, it's from thunderstorms and nor'easters. It's all three of them. And ironically, we also will get some additional summer drought, more summer drought than we're used to. Again, I know it sounds like I'm trying to have my cake and eat it too, but it's true. So again, we got to reduce our carbon emissions as much as possible, but also adapt to these changes that are already happening that are going to be unavoidable. So let's talk about solutions. How do we get there? Well, we've got to decrease CO2. And so the first question is, where is our CO2 coming from? Okay. If we just look at our country, let's just take our country. Number one is transportation. And I've broken it down into cars, trucks, and planes. You can see cars is 60%, trucks is a quarter of it, and planes are 15%. And then after that is electricity. And look at this big one, coal, right? What's interesting is that coal only right now represents like 25% of our electricity nationally, which is crazy. Just a decade or so ago, it was 50%. So coal has plummeted, but yet look at how much CO2 it produces, even though we get twice as much electricity from natural gas as we do from coal. But the problem is that coal puts out twice as much CO2 for every unit of energy that you produce. We've got to get rid of coal. If we do nothing else in the near term, let's just get rid of coal. And then industrial, residential, commercial go down from there. But I think I would encourage everybody who's concerned about this and thinking about this, there are some really good websites, I can send you some, to calculate your own carbon footprint. See where your own carbon emissions come from. I've done this a lot, and it really forces you to think about the choices that you make in day-to-day life. And I have a lot of reasons to be optimistic. I know this probably all sounds horrible. I want to make it clear. I'm actually an optimist. I think we're going to deal with this. I think we can, I know we can deal with this, and I think we will deal with this. I think we will get on a better path. I do not think we're going business as usual. I think we probably won't go as aggressively as we could or should, in my opinion, but I think we're going to start acting actually in the pretty near term. And we've already started in some ways. So let me tell you why I'm optimistic. Let's think about transportation, right? The cars, that was a big one. Look at how many available models of electric or plug-in hybrid or fuel cell cars that we had all the way up until 2011. Essentially none, okay? Lots of ones and twos there. And then look at what's happened just in the last decade, okay? The electric car, transportation is going electric. It is the way of the future. It is the way of now, okay? Transportation is going electric. And while that doesn't solve all your problems, it is far more efficient to produce electricity in a centralized power plant. Even if it's coal, it is far more efficient than putting gasoline in a car engine, okay? But the thing is, it doesn't have to be coal, because you can get that electricity from a renewable source like wind or solar, and then you essentially have no emissions. All right, so this is optimistic. And if we look to the future, look at these projections. The car industry is already there. They are going this way, regardless of what the federal government does. I mean, I think it was really interesting when the administration decided to reduce fuel efficiency standards. The car industry said, no, we don't want you to. That's remarkable. So this is where we're headed, electricity for our transportation. And then think about renewable energy. When I would teach, I've been at Dartmouth since 2007. It's a long time. When I would teach about renewable energy back in 2010, 11, 12, a lot of students would ask me, what about solar? What about solar? And I would just say, it's so far away. It's too expensive. It's just a pittance. It's just a tiny amount of our electricity. It's a long-term future solution, but we're nowhere near there yet. But look at what solar has done in the last decade. I was wrong. All right, we have seen an explosion of solar, a 75-fold increase just in the last decade. And that includes locally here. And then wind is actually 10 years ahead of solar. So these blue bars are the same solar plots I just showed you. And I should have mentioned that this is all the amount of electricity they produce on the vertical axis here. Okay, so wind is already ahead. Wind has been blowing up since the mid-2000s, since around 2005 to 10. And now we're starting to see solar. And the question is why? What's happening here? It's all about the price. Solar was insanely expensive just a decade ago. Somewhere around $300 in order to produce a unit of energy. Doesn't matter what that unit is. Just think a unit of energy used to cost $300. And wind was still really expensive at, say, $140. But look at how those prices have come down. Now solar is around $50, a dramatic crash in its price. And what's critical is that it is now cheaper than coal. It is now cheaper than coal. Both wind and solar at the industrial power plant scale are cheaper than making a new coal power plant. There is zero reason to produce a new coal-fired power plant now. And so, renewable energy is taking off because of price. That's also why natural gas is replacing coal so quickly, is because it's so cheap. It's all over the place because of the natural gas we found all over the country in the last decade or so. But now solar and wind are even competing with natural gas. This is a critical turning point, because now it's not just environmental groups trying to push this. It just makes good business sense. If you want to produce electricity more cheaply, you go to renewable sources. And think about this. The reason these prices have come down is because we keep scaling up the technology and getting better at it. But the source of the electricity is limitless, right? The source of the power, the sun and the wind, is essentially limitless. So those prices are only going to keep going down as technology gets better and better. Whereas coal and natural gas, all fossil fuels, there's a limited amount of them. It's a finite resource. And so as we keep using them, their price is only going to go up. So we've already crossed that critical threshold where renewable is cheaper, and it's just going to keep going in those two different directions. And I think we need to dispel this myth that you can't reduce emissions while growing your economy, that you have to choose. It's either a good economy or it's a good environment or climate. You can't have both. Well, this is what New Hampshire has done. In green is our economy, gross domestic product, GDP. And going all the way back to 1990, you can see we've been growing quite nicely. And you can see that our total CO2 emissions were growing with it all the way up until a peak in 2004. But since 2004, emissions have gone down 35%, while the GDP keeps going up. we can grow the economy while being good stewards of the environment and the climate. And this was almost entirely driven by less CO2 in the electricity sector because we switched mostly from coal to other sources, including natural gas. It'd be better if we didn't have it, but including natural gas, that actually helps versus coal, but also increasing renewable sources and also some nuclear sources. And so, there's more and more analyses like these that US companies could save billions of dollars just by closing their coal plants. And it's not just the US. China could save hundreds of billions of dollars. The EU could save billions of dollars. Russia could save billions of dollars. This is going global. And I don't often talk about this to all my audiences, but because you are a faith community, I think this is frankly what troubles me the most is everything I've talked about has really been focused on us, right? What's going to happen to us? And that's because for most people, that's what they want to know. What's going to happen to me, my family, my kids, my grandkids. But I think this is the real challenge, that if you go outside of our communities, outside the United States, the people who are least responsible for climate change are the ones who are affected most severely. And what is our obligation to those people who have had nothing to do in many cases with causing the problem, and yet they're suffering the worst? And I just want to give you two quick examples and then we'll wrap up. So one here is in Vietnam. So we talked about sea level rise. Vietnam has this enormous population that all lives very close to sea level, within several feet of sea level. And so the estimates are that within a few decades, 2 to 7 million people in Vietnam are going to be displaced by rising seas. We talked about some of our hurricane catastrophes here in this country. Some of you, I'm sure all of you who are old enough remember Hurricane Katrina, right? Where we lost somewhere in the order of 3,000 lives down in the Gulf states, Louisiana. This is Bangladesh's Katrina, okay? They didn't lose 3,000 lives. They lost 500,000 lives. And it's because of the difference in infrastructure, medical care, preparedness, warnings, that these impacts, the same kind of storm that was devastating to Louisiana, you can imagine what it was doing, what that kind of storm did to Bangladesh, okay? And so as we think about this, we could think about the amount of CO2 that these different populations in these different countries produce. And again, the units don't really matter here. It's the difference between the numbers. So the USA, we are really bad when you compare us to other countries. We're at 20. And people love to point their finger at China because China does produce more CO2 than we do now. But we've been doing it for a lot longer than China has. And still, if you divide it by the number of people, they produce less than half per person that we do. The UK is around the same at 8, Sweden's 5, and these are places that have very high standards of living, right? Vietnam, Bangladesh, we produce up to 20 times more CO2 per person than these places. So these places are not causing the problem. The problem is from the industrialized Western world that has been burning fossil fuels for, well over a century. So I always like to finish with this. What can you do? These are the things that I try and do, the things that I'm focused on in my own personal life. Purchasing renewable power. I'm trying to get solar panels on my roof. We have too many trees and I really don't want to cut them down. So right now we're talking to Norwich Solar about doing community solar, having the panels somewhere else, and then we get the credit for it by paying for it. Think about energy when you make major long-term purchases like buying a home, buying a car, buying an appliance. These are things that are with you. You're determining much of your emissions for several years, and in some cases would say a home for decades. And so I talk about this a lot with my college students because they're about to go out and perhaps buy their first car, perhaps buy a bunch of appliances, buy their first home within a decade probably. And I like them to be thinking about these things. Think about energy when you make those big purchases, and then you get to benefit from those wise choices for decades. If you do your carbon footprint calculation, at least what I found and what a lot of people in this region find is that airplane flights are a really big portion of your carbon emissions. So try skipping a flight. We've all gotten used to Zoom. We're Zooming right now. So start Zooming instead of traveling for business, right? When I went to Miami, I offset my carbon emissions that the flight cost. And frankly, I don't even know for certain if those offsets are real. But at worst, I donated some money to a good cause. At the best, I was able to offset my carbon from that trip. It's probably somewhere in the middle. Eat less beef. This is something my family is doing as well. There's a huge difference between the carbon impact of beef versus other meat. So chicken or pork have much lower carbon emissions than beef. Or of course you can go fully veggie or vegan, and that has a huge impact on your carbon emissions. And then support local companies that prioritize this sort of thing, buy local products. And then, you know, I talk about this a lot with my students who don't vote enough, but to support people who really prioritize this and vote, because if we prioritize this, they will start prioritizing this. So thanks for sticking with me. I know it's late, and I'm happy to take any questions either now and also by email. You can always reach out to me. I love getting questions and talking to people. And deathly silent. The joys of talking in the Zoom world. I think everyone fell asleep.
No, we were just all muted. That was great. So halfway through your talk, as I was getting depressed, I wrote up a question about what can we do? What would be your top 5 things we could do? And you just answered them.
Yeah.
So, but
you know, and I think it's different for every person, right?
Yeah.
Part of it is based on your particular carbon footprint, but it's also, these are our lives. People are comfortable with different changes in their life. And, you know, we bought a Prius 10 years ago, just before our first child was born, because we wanted to put our money where our mouth was. Like, I've been studying this a long time, and I thought I wasn't going to like the car, but I really needed to do it to make a difference. And I ended up loving that car. It was like my favorite car. And then, like, we somehow convinced ourselves that we needed a bigger car because we had kids. And so we traded that car in, and like, it kills me. It kills me that we did that. I wish we hadn't done that, but we did. And I've done all the calculations to figure out, like, how long do we have to have this other car before I can trade this one in and it be worth the carbon that it costs to build this car, right? So everyone's situation is different, and everyone has different things that they're comfortable doing. Some people, you know, eating less meat or going veggie, that's just a non-starter.
Mm-hmm.
That's fine. That's your personal choice, but maybe there's something else that you can do.
Mm-hmm. Yeah, no, very, very well done. Thank you so much. Everyone else chime in with questions.
Erich, I have a question.
Yeah, you can ask questions or chat maybe, either way.
I have a question. You said something interesting about we have to adapt to some of the things that are already changed that we can't really go back on. Can you speak to that a little bit more? Like, does that mean like relocating people like out of Miami, or what is your take on that?
Yeah, I mean, it means different things in different places to different people. If you're talking about Miami, as I said, like that is a really hard situation to see good solutions for. I mean, the best solutions I can see is literally, you know, something like Venice, where you just start raising things up and the roads turn into canals, and you just build all the infrastructure, all the buildings, all the roadways, you just build them to flood, and you expect them to flood, and you know they're going to flood, and you just build them that way. You know, that takes a long time. That takes decades, and that takes billions and billions of dollars. And so, you know, the way I talk to Miami about it is like, you folks have to choose. Like, do you want to move? Like, it's up to you. Do you want to get up and move and relocate personally, your family, or do you want to stay here and try and make this work? And I'll bet you they can make it work. I'll bet you there are solutions. Is it worth the money? Is it worth, you know, the fact that it's just going to keep going? Like, the sea level is not just going to stop. So whatever they do, they're going to have to keep doing it. That's up for them to decide. Around here, you know, I think more about, okay, we have more frequent flooding, these more frequent extreme storms. How can we make those less damaging, less impactful, right? And it's really, really boring, but it turns out that you got to build culverts, those big pipes that go under roadways, you got to build them a lot bigger. And that's so boring. Like nobody wants to talk culvert size, but it turns out that that is critical. All those pictures I showed you, if we had better sized culverts, those damages don't happen. So, you know, it's thinking forward as a town and saying, okay, well, if we're going to replace this roadway anyway, we're already tearing it up. Why don't we have the forethought to put in a much bigger culvert than is already there? And that costs a little extra increment, but that's going to save us a ton of money a decade from now when the next extreme storm happens, right? Or if you're a farmer, how do you adapt to these changing climate situations? And so I've got some personal friends I went to college with. They're now farmers here in Vermont, and they're working really hard at figuring out how, as farmers, can we adapt our practices, our farming practices, the way we treat our crops, the way we treat our fields, the way we treat our livestock, in order to adapt to these conditions so that they don't damage our crops, damage our livestock, right? And so we need to be doing both of those things, trying to reduce it as much as possible, but then also trying to reduce the impacts from the things that we can't stop in terms of climate change.
Eric,
Yeah.
I have a question. Is there some data that can tell us what would happen to the impact on CO2 and on the economy if the entire nation went veggie?
Yeah, you could figure that out. I don't have that at the top of my head, but I'll tell you this. So the beef industry, it's somewhere around 15% of our total greenhouse gas emissions as a nation. Now, most of those emissions are from methane, cow burps, frankly. We talk about cow farts, but it's actually mostly cow burps.
Yeah.
But so that's 15% in this country. But if you look national or internationally at the whole sort of beef industry, it's a much higher percentage. It's something like 25 or 30%. And don't quote me on that, but it's ours is low at 15 because our other emissions are so high. It's a smaller percentage.
Sure.
But if you go to other parts of the world, it has a bigger impact. And so, you know, I think personally, part of my personal journey on this is that I didn't really pay much attention to vegetarianism and the impact of beef because I really liked beef, and I probably didn't want to hear it, but it is unavoidable. So I had a group of students who were working on an app, a web page, where you could go on, you could put your own carbon footprint, and then it'll tell you what are the 5 best things that you can do. And it's really hard to get away from eating less beef if you live in sort of this area and are sort of like a standard person's footprint in this area. So my family has taken that a lot more seriously. And again, like chicken, it's about 1/10 of the amount of CO2 emissions as beef. So it's a huge difference if you're just switched to other forms of meat, if going totally veggie is too difficult for you.
Eric,
As it is, I think, for my family right now.
can you stop screen sharing so we can see everybody?
Yeah,
Oh, yay.
it's a cute pup.
Eric, what advice do you have for Dartmouth about their heating plant?
Great question.
Oh, boy.
Great question. Are there any Dartmouth administrators on the call here?
No, we won't say.
So I've had a soapbox for a long time about this. I think in general, my vision for Dartmouth is that we should be leading the way in terms of going carbon neutral. We are the smallest Ivy League. We live in the woods. We already attract students who tend to be more environmentally conscious, like to be outdoors, or more in touch with the environment naturally. Like I said, we're the smallest, so it would be the easiest for us to do of all the Ivy Leagues. And for, you know, our mascot is the big green. So we should be the green ivy. We should make that a critical part, a core part of our brand, of who we are. You know, advertise Dartmouth as come up to, you know, New Hampshire woods, learn about how to live sustainably. And we're just, you know, we've been focusing here on CO2 and climate change, but in general, sustainably, right, with the natural world. And while you're here learning about this, how to become, you know, a leader in whatever you want to do afterwards, walk the walk. Spend your 4 years in Hanover and see that it can be done. Walk the walk as a carbon neutral person for 4 years here, so that when you go off and you start your big business, or you run for Congress, or you do whatever you do, you raise your family, that you understand that it can be done, and that you're not, you know, living in a cave or something ridiculous like some people will say. So that's my personal vision. In terms of the heating plant itself, I'll say again, I've had a bit of a personal journey on that. When I first heard these critiques, I was really excited about the heating plant, the wood burning plant. I was really excited about it because it was a huge step in the right direction. And I was a little upset when people started protesting against it, because I was worried that the response of Dartmouth would be, okay, well then we're not doing anything. We'll just stick with the oil. And I was really impressed that that is not what happened. That instead Dartmouth paused and they listened. They listened to alums who were experts. They listened to the local community who said, we don't want another incinerator, you know, spewing stuff here. And so I personally started researching more about, you know, the pros and cons of biomass burning. And it's a really interesting and tricky issue. Like, how carbon neutral is biomass burning really is a really tricky issue. But if the answer ends up being, let's not do that, let's go to a non-combustion future for Dartmouth that includes more renewables, more heat pumps, that's a great, I mean, that is a win. That is huge, because no matter how good biomass is, if we can do something better than that, that's awesome. And I'm pleasantly surprised that that's how things went. Now, with the budget crisis, we'll see. You know, I think Dartmouth is in real budgetary crisis, and we were in budgetary trouble before COVID. And a part of it was the massive infrastructure transformation that it's going to take to change the steam pipes into hot water pipes, and that has now been put off. And so my concern is that with the focus on budget for the next, say, 5 years, I think is realistic and perhaps optimistic that we're in a real budget crunch for 5 years now. My worry is that these larger green ambitions kind of fall by the wayside for a while. So I'm hoping that doesn't happen. I hope we actually see it as an opportunity to grow in a new direction, but we'll see. I'm working hard. I'm on the president's Sustainability Advisory Council, the Dartmouth president's, not the US president. And you know, I don't know if he listens to us, but this is what we're telling him. So we'll see.
Eric, I think someone asked a question in the chat that was if you would speak to if solar panels pay off in the long run, like if they're cheaper in the long run, or what you can say about that.
Yeah, so is this in regard to Michael Moore's new movie, maybe? So, you know, I love solar. I don't quite know what Michael Moore is up to with this latest film, where he says essentially that solar is, you know, not just solar, but solar and wind are not worth it in the long run. That's just not true. And it, you know, I've seen a lot of scientific rebuttals of this latest film, and again, I don't get it. I don't understand where this came from. Gail, do you have something you want to add?
Oh, I just posted a comment that we love our solar. We put it on a couple of years ago, and you know, our electric bill wasn't high to begin with, because our house is heated from propane, and we did put in some heat pumps, but we do still need to use propane. But
yeah, I don't understand.
For us, it was, you know, we're accumulating so much credits and putting the electricity back into the grid. So I think we're providing electricity to 10 people.
Right.
with the amount we generate. We have such a sunny exposure. We hardly use any of it. And so to me, it's well worth it.
Yeah, like I say, we want to go solar, and I think we're going to go the community route, just because of where we are in the woods. But yeah, I don't understand those arguments against solar.
I haven't seen his movie yet.
No, I haven't either. I don't.
Don't
I
waste your
probably
time.
should.
Don't waste your time.
I won't.
Hey, well, thank you, Erich Osterberg. We can't thank you enough for getting us off to a great start with our monthly series. We really appreciate
Sure.
Thank you for your patience in our rough start, but
Keep
we
doing
did
what
get
you're
off to a
doing.
great start once we finally got going, and we will make this available. Even just while you were presenting, right at the end, I got an email hoping it was recorded. So, there'll be people out there
Great.
who will continue to benefit from what you've shared.
And yeah, feel free to reach out to me if you have follow-up questions or looking for resources. This is what I love to do. So I'm happy to get those emails.
Yeah. Okay. Thank you.
Take care, everybody.
You too.
All right. Thank
Bye-bye.
you. Bye, everyone.